The following frequency distribution shows the number of classes a sample of CCC students are taking this semester. So the first row, number of classes 1, has a frequency of 6, just means that there are 6 students who said they're taking 1 class. The next row, there are 14 students who said they're taking 2 classes. So if we look at the total number of students that were asked how many classes they're taking, so our sample size here, if we add all the frequency up, we end up with the sum of the frequency being 150. So that's just saying that 150 students were in this sample. We're going to let random variable x represent the number of classes a student is taking this semester. So the values that x can take on, in this case, are 1, 2, 3, 4, 5, or 6. So those are all the possibilities for random variable x. Number 1 asks us to construct a probability distribution for x. So a probability distribution is just asking you, for every x value, can you write the probability of that x value? Okay, so in the first row, we had 6 students say they're taking 1 classes. Well, the probability that a student said they're taking 1 class would be 6 out of the total frequency, so the total number of students, which was 150. So 6 over 150, which if you divide that, you end up with 0.04. Okay, and if you go through and do that, for every x value, every number of classes, the next one will be 14 over 150, and then for 3 classes, you'd have 18 over 150, and so on. So when you do that, you end up with those relative frequencies. Okay, these numbers may be slightly different just depending on rounding. Because you're looking at 0.040 as being 4%, you don't want to round too much. Okay, so I'm not going to give any specific round off rules for these, but you don't want to round too much. Okay, so the probability distribution that they ask us to create for random variable x, that's just listing all the values of x with their associated probabilities. So for the x value of 1, the probability of a student saying they're taking 1 class was 6 out of 150, which is 0.04. The probability that x is 2 is 14 out of 150, or 0.093. Okay, so all that a probability distribution is a list of all possible outcomes, 1 through 6 in this case, and their corresponding relative frequencies or probabilities. Okay, so that's a probability distribution for random variable x. Okay, there are several basic probability properties. Okay, the first one being the probability of an impossible event is 0. So, in a different example, suppose if you toss a fair 6-sided die numbered 1 through 6, the probability of rolling a 7 is 0 because you cannot roll a 7. The second property, the probability of a certain event is 1. So if you roll a fair 6-sided die, the probability of rolling a number less than 7 has to happen. So there's a 100% chance that that happens. So 100% chance meaning 1 or 1.0. The third rule, the probability of any event is between 0 and 1 inclusive. So this is mathematically how that's written. The probability of any event A is larger than or equal to 0, but less than or equal to 1. So any probability is between 0 and 1. So if someone told you the probability of something happening was 1.35, okay, that cannot be true. It has to be a decimal or some value that reduces to a number between 0 and 1. The fourth rule, the sum of all probabilities, or the sum of probabilities for all possible outcomes is 1. So the sum of P of A, so the sum of all probabilities must equal 1. So if you look at rolling a fair die numbered 1 through 6, the sum of all probabilities must equal 1. In that case, meaning rolling a 1 or rolling a 2, 3, 4, 5, or 6, if you add all the probabilities up, you should get 1. So that would be probability of 1 is 1/6. Probability of a 2 is 1/6. Probability of 3 is 1/6. If you add all those up, you get 1. And then we have the complement rule, which is the probability of an event not happening. So the probability of not A is 1 minus P of A. So let's just say that event A was rolling a 6 on a fair die. The probability of not A would mean the probability of not rolling a 6. So that would be 1 minus 1/6, which would give you 5/6. The complement of an event A, you denote that by A with a bar over it. That consists of all the outcomes in event A which does not occur. Okay, do not confuse the A bar with X bar. They are not the same thing. Okay, remember the sample mean is X bar. These are not the same concept here. This is just the notation of how you write the complement of an event A. Okay, it does not mean the same thing as the sample mean. Okay, so the last few examples. So in this case, to find the probability that x equals 3. So in our example, that's the probability that a student said they're taking 3 classes. So if we go back to our probability distribution, the probability that x equals 3 is 0.120, which was 18 out of 150. Okay, so that would be 0.120. The probability that x is less than 3. So if x is less than 3, that means they could have said they're taking 1 or 2 classes. So the probability of 1 or 2, you'd be looking at the first 2 rows, which is the 6 out of 150 and 14 out of 150, or 0.04 plus 0.093. Okay, so if you add those together, you would end up with 20 out of 150, or 0.133. The probability that x is greater than or equal to 5, so that could be 5 or 6, because notice there's an equal to with this one, so that means that 5 is included, whereas over here, x is less than 3, the 3 was not included, because there's no equals with it. So 5 or 6, you would take the probability of 5, 0.213, plus the probability of 6, 0.067, and add them together. And you end up with 42 out of 150, or 0.280. Okay, so that's just a basic example of working with a discrete probability distribution. Okay, and all that discrete means is there's a countable number of outcomes, while the number of classes a student takes were 1 through 6, which are a countable number. Compared to a continuous distribution, like the normal curve, where it's a continuous axis rather than a discrete.